Okay, so first we're going to talk about the nomenclature of ketones and aldehydes. Ketones are designated with the suffix -one, O-N-E. Aldehydes are designated with the suffix -al, A-L. In terms of the functional group priority here, ketones have the lower priority, aldehydes have the higher priority in terms of determining which one is located in the parent chain. Overall, we've talked about three functional groups now: alcohols, ketones, and aldehydes. Of those, the alcohols are at the bottom of the list, the aldehydes are at the top of the list. We'll expand on this list later as we add more functional groups. Only the highest priority functional group is counted as the functional group. Any others on a compound are named as substituents. So as an example of this, let's take this compound here. The highest priority functional group that we can find is the aldehyde, which means the parent chain of this compound contains only these three carbons. The parent chain must contain the highest priority functional group. So the parent for this compound would be named as propanal. Notice that there's no locant here. We don't need to add locants for aldehydes because aldehydes are always at the end of a chain. They're what are known as terminal functional groups. Since the aldehyde is the highest priority functional group, that means that the alcohol is going to be treated not as a functional group with the OL suffix, but as a substituent named as hydroxy. So if we look at this, this means that this compound has a complex substituent, a six-membered ring, which also bears the OH group as a substituent. So putting it all together, we would get this name, 3,2-hydroxycyclohexylpropanal. The way that ketones are named is very similar to alcohols. So if we have a compound like this here, we would identify the highest priority functional group, here the ketone, and assign it the suffix O-N-E. We would number the chain. Like an alcohol, the ketone must be located because it could be located on more than one atom in the chain. So when we put this all together, we could call this 2-butanone. This is the naming system that the Klein book uses. However, this is the older IUPAC system. I'm going to recommend that we use the new system that locates the substituent with an infix. So we should call this more properly butan-2-one. If we have a compound like this, we would follow the same process. This compound here is actually, goes by the common name diacetyl. This is one of the primary flavoring ingredients in artificial popcorn butter. It is not so good for you if you breathe a bunch of it in. You can get a condition that's known as popcorn lung. Is known by the terrifying medical name bronchiolitis obliterans. So if we were naming this, we would follow the same process, number the parent chain. Here, since we have two functional groups, we would add the di prefix to say that we have two of these things, ended up with the name butane-2,3-dione. So this is how we would do it if there's multiple functional groups. The same process works for aldehydes. All right, how about an example like this? So in this compound, the parent functional group is obviously the aldehyde, which means that we have this 5-carbon parent chain numbered like this from our highest priority functional group. So we start with hex, 6 carbons. We have a double bond at carbon 3, 3-ene, and we end with the functional group suffix al. Hex 3-enal is the parent name of this compound. Now in this case, the ketone carbonyl group has to be named as a substituent. The way we do that is we call it oxo. So here we would say 5-oxo. That would tell us that on carbon 5 there's another carbonyl group, this time of a ketone, and that would be the name of this compound, including all functional groups and substituents. The last thing we have to remember, though, is that we have a double bond that could generate stereoisomers. So don't forget stereochemistry. We have to put the stereochemistry for the double bond. Here trans or E would also work for this. So trans 5-oxo hex 3-enal would be the proper IUPAC name for this compound. There are some common names that we need to know, just like for the aromatic chapter. This 1-carbon aldehyde is called formaldehyde. This 2-carbon aldehyde is called acetaldehyde. These are both very important, and they're also frequently referred to by their common names. There's some ketones as well. This 3-carbon ketone, you use this in the lab as a solvent. This is acetone. Another one that we'll need to know is benzophenone, a ketone that is bound by 2 phenyl groups. Common names for ketones are often used. They're generated sort of like we did for ethers. So if we were naming this ketone here, what we would call it is methyl ethyl ketone. That's its common name. Unsurprisingly, there's very little creativity involved in generating a common name. We have a methyl group, we have an ethyl group, we have a ketone, hence methyl ethyl ketone.